Hi, I'm Danny Flanigan. I am the product manager for imaging and impedance systems at Axion Biosystems. ADCs are antibody-drug conjugates. They're a very promising modality of therapy, particularly in the oncology space. I think some common difficulties with assessing particularly cytotoxicity in ADCs are the necessity of running endpoint assays, particularly if you're trying to get a sense of the temporal dynamics of your data. It can be very challenging with endpoint assays because that requires running multiple different time points, and that introduces potential for variability and user error. With Maestro Z impedance-based cytotoxicity assessments, you don't need to label your cells and you don't need to run terminal endpoint assays, so you really just put your cells in your plate, you add your treatment, and you put it on the instrument, and it goes and continuously monitors your cells over time, so you don't need to do multiple endpoints. In the app note, we took a look at two different ADCs. They were payloads conjugated to the same antibody targeting HER2. And we also took a look at two different cell lines, one overexpressing HER2 and one with a lower expression of HER2. And we tried to assess the differential responses of these two cell lines to these two different ADCs using impedance. We were able to identify one of these ADCs actually had faster, more complete killing than the other in our high HER2 expressing cells, and we were also able to demonstrate differential responses based on antigen expression with those two different cell lines. There was a difference in that one of the treatments definitely worked faster and killed more completely than the other. So with endpoint assays, you would really only get information from the time that you take your measurement. So if you were to take your experiment out to 96 hours and take your endpoint measurement, you could compare the level of cell death at that time point, but with kinetic information, you can get everything in between that 0 and 96. So we were able to see faster killing with our one experiment, whereas with an endpoint assay you would have to run multiple experiments to get that sense of time. Anyone currently measuring cytotoxicity with ADCs would benefit from reading this app note. We demonstrate our impedance-based measurement is robust and can detect differences from antigenic expression to different payload effects, and anyone interested in cutting down the time that it takes to run these laborious endpoint assays or just learn more about impedance technology would benefit from